Now class, there are three formulas that you need to remember to answer question regarding average atomic mass, AAM, RAM is a relative atomic mass, and RMM is the relative molecular mass. So the formula for AAM would be sum of Kimi over Q. So Q is the abundance of your isotopes and M is the mass of your isotope. And K is the over sum of K is the total abundance. Average atomic mass has a unit of either U or AMU. For relative atomic mass, the formula is mass of an atom divided by 1/12 times mass of carbon 12. Relative molecular mass, it is just the same with relative atomic mass. It's just that for RMM, we are looking for the mass of a molecule divided by 1/12 times mass of carbon 12. For both relative atomic mass and relative molecular mass, you are relating two mass. Okay, so the mass of an atom has a unit of U, and the mass of carbon 12 has a unit of U as well. Okay, so cancel off this U unit, so you are left with no unit. For both relative atomic mass and relative molecular mass. So remember class, the one that got unit is the average atomic mass. Okay, relative has no unit since you can cancel off the unit together. For abundance, there are two types of abundance, which is percentage abundance. Okay, so for percentage abundance, if you want to calculate percentage abundance, that would be 100 minus X. But for relative abundance, the calculation would be in 1 minus X. So let's try the first question. It has been found that mass spectrometric analysis that the relative abundance of the various isotopic atoms of silicon are 92.23% 28 silicon, 4.67% 29 silicon, and 3.10 30 silicon. So the isotopic mass of these three isotopes, so we are given the mass are 27.7 U, this one, and this one as well. Sorry, I'm just too lazy to read all the questions. So the question asks to calculate the relative atomic mass of silicon. Okay, the first thing that we want to do is we want to separate the information respective to the isotope. So for 28 silicon, the abundance would be 92.23% and the mass would be 27.977. For 29 silicon, there would be 4.67% and the mass would be 28.976 U. For 30 silicon, there would be 3.10% and the mass would be 29.974 U. So the question asks to find the relative atomic mass. So let's go back and check what is the formula for relative atomic mass. Okay, so that's the one. So relative atomic mass is the mass of silicon divided by 1/12 times mass of carbon 12. So we don't have the mass of silicon yet. Okay, so we need to find it by using average atomic mass formula, which is sum of Qm over sum of Q or abundance. Okay. Just remember, if you are given this kind of information, then you have to use this Qm over Q formula. That's easy. Okay. So the abundance, there would be 92.23 times 27.977 U plus Qm for 29 silicon 4.67%. Sorry, you don't have to write the percent. Times 28.976 U plus 3.10 times 29.974 U divided by the total abundance, that would be 92.23 plus 4.67 plus 3.10, which would be 100%. So this would result in 28.09 U. Okay, don't forget this unit of average atomic mass. So we're gonna try to find the relative atomic mass. So just include this number in this equation. Okay, so the mass of silicon isotopes would be 28.09 U, and the mass for carbon 12 would be 12 U. Okay, so just cancel the U together and this 12, so the final answer would be 28.09 only. Okay, remember that when I said that relative does not has any unit, because we already canceled this unit together. Okay, so for my tutorial, I always provided the final question because it will be easier for you to check out your answer by yourself. And one thing I forgot to mention, that for chemistry SK015, your calculation must be in 4 decimal place, but your final answer must be in 2 decimal place. Okay, there's no compromise in this. So what if I write this final answer as 29 only? So you've got the final answer as wrong. Okay, so that's totally useless. Okay, remember, the final answer must be in 2 decimal place and the calculation must be in 4 decimal place. So let's continue with question 3 because it involves ratio. So determine the relative atomic mass of element Z if the atomic mass ratio of Z to carbon-12 is 1.17. So this is how you extract this information. So for this question, the mass for carbon-12 is not 12 anymore. Okay, and why is that? It is because for the ratio of Z over carbon-12 equals to 1.17, it must be over 1. So the mass of Z is 1.17 and the mass for carbon-12 is 1. So let's figure out the relative atomic mass. So the mass of Z divided by 1 over 12 times mass of carbon-12, which is equal to, so mass of Z would be 1.17 over 1 over 12 times the mass of carbon-12, again it is 1. So the final answer would be 14.04. So you tried the question 4, which is not given in ratio but in multiplication, because the question said heavier, more. Alright, for question 5, 6, and 7, I'm going to give you the hint how to solve it. Okay, so the rest I want you to do it by yourself because it is quite easy and you guys just need some guidance to do question 5, 6, and 7. For question 5, the isotopes of silver occur as 107 Ag and 109 Ag with mass of this one and this one. So you are given the average atomic mass of 107.868. What would be the percentage abundance of these two isotopes? Okay, when mentioning about abundance, you know that you gonna have to use the Aam formula. Okay. But first, let's extract out the information. For 107 Ag, the mass is 109.906. For 109 Ag, the mass is 108.868. So let's substitute the mass information into Aam formula. So average atomic mass is equal to sum of Chemi over Q. Okay, so we don't know the abundance for both isotopes. Okay, so since the question asks you for the percentage abundance, so you can assume that the percentage abundance for 107 Ag to be X, and the percentage abundance for 109 Ag to be 100 minus X. So let's substitute this percentage abundance into this formula. So the average atomic mass is given already, 107.868 equal to 109.906 times X plus 108.868 times 100 minus X. So you finish off this question and you should be able to get the percentage abundance in this final answer. Okay, you can compare it. For question 6, for question 6, it is the same as question 5, but question 6 mention you to find the relative abundance. Okay, so what you need to change is, remember in the formula, okay, for relative, your second isotope abundance must be 1 minus X. Okay, so I'm just gonna write it here because I don't have any space below. So the relative abundance for 79Br would be X. For 81Br, the relative abundance would be 100 minus, that would be 1 minus X. Okay, so just substitute the information into the formula and you should be able to find the relative abundance in this number. Okay. I'll give you the hint for question 7 as well because the information is in ratio form. So chlorine has 2 isotopes, which is in the ratio of 3.1 to 7, and you are given the mass as these numbers in the question. So the first question, calculate the percentage abundance of each chlorine isotope. So again, like question 2, if I'm not mistaken, the ratio should be written 35 Cl over 37 Cl is equal to 3.127 over 1. So 35 chlorine is 3.127. Sorry, the abundance for 35 chlorine is 3.127. And for 37 Cl, the abundance is 1. But the question asks you to find the percentage abundance. Okay, so I'm gonna show you how to find the percentage abundance for 35 cl only, and you carry on the rest of the question. So 35 cl, the abundance is 3.127 over the total abundance times 100%, because we're gonna find percentage abundance. So that would be 75.77%. So next, you're gonna figure out the percentage abundance of 37 cl and answer the question B as well. And I'm gonna leave you the question 8, and I'm gonna check it in the next class. Okay, try to figure it out by your own.